I'd like to give an introduction to the true value of pi. We know that our legacy from the time of Archimedes established for their time an amazing relationship that pi, which is traditionally 3.141, was based on the diameter of the circle relating to the circumference. So we know that when the diameter of the circle is 1, how many times is that distance of 1? Imagine it was like a shoelace. So it goes 1, 2, 3, but there's a little bit there. So this discussion today, an introduction, is to show that the ancient people knew that pi was close to 3.141, and they symbolized it as a fraction. So Archimedes, 2,230 years ago, did a thing called the Method of Exhaustion. It was using lots of polygons to establish that the approximation for pi was 2217. Now that's the key word. When I said approximation, so over 2,000 years ago, they only approximated pi, but we still believe today that the traditional value for pi is 3.141, and we will establish in this series of lectures that I'm going to give on pi that when we understand the harmonics of the circle is based on the golden ratio, we're good. We know that we've corrected the misinformation about pi, which is what I'm going to show. If we look at this diagram here, we're going to see that there's a circle. Imagine that circle is like a pizza, and we've divided the circle into 16 different pizzas. So here I've highlighted one pizza, and it looks like a triangle with a straight line. And what I'm going to show soon is the error in pi is based on the assumption that there is an area under the curve that's highlighted in black, and the ancients believed, or Archimedes believed, that that area under the curve magically disappeared. So that's the error. So let me talk about Archimedes before I draw this. Archimedes in his time was under a lot of aggression from the Romans. So he, as a genius for his time, he designed all the weapons of war for the Greeks. So he invented catapults and levers and those things with burning mirrors where ships could burn each other by angles of reflection of light, just to keep the Romans away. So this has a basis. This story about pi actually has a military history. And even in physics, the physics that we use today on hydrostatics and buoyancy was all developed by Archimedes. Most people know that when he was laying in the bath, he had a great idea about buoyancy, about when something is displaced, an equal volume is upplaced. And so he's running down the street in ancient Greece naked, screaming out Eureka, Eureka, which means I have discovered it. So this is a tribute to a great mind called Archimedes, because for his time to establish that pi was close to 22 divided by 7, that's pretty good for his time. But remember, it's only an approximation. So what I'd like to do is I want to show how we got this diagram. So I'm going to come to the board here, and when we draw, we know that when we draw the circle, we could inscribe a triangle, which is the first form. But let's say we put in the first square. So we know that the area of the square is 1, 1, 1, 1. That's not 4. But then when we draw another square over the square to get an octagon, the distance under the circle here is just a little bit less. You can see that we're interested in this straight edge. But I could keep dividing it again. So if I just go midpoints, I could draw another square over here, and you can see as I keep drawing squares and squares, we get what's called an area under the curve. So here's the straight line. So this is a polygon. So Archimedes kept increasing the number of polygons from 4, 8, 16, 32, 64. I think he got up to like 128. He got really high, and he measured all the different area, the straight line lengths going around. And this is the fundamental error of pi, is that the fundamental error of pi is that we assume that the area under the curve, that little section under the curve, just magically disappears when we increase or exhaust the polygons from 4, 8, 16, 32, 64, 128. So that was the problem. So it wasn't until So what Archimedes did was develop calculus. He set the pathway for us to learn this high-level maths called calculus. You know, like when you shoot a cannonball, it makes a curve in space. By measuring the area under the curve, we developed this thing called calculus. Anyway, so the story is Archimedes, will give Archimedes a green tick to say, yes, he established that pi was the sum of millions and millions of straight lines, which in maths is called the limit of many, many polygons. But he didn't actually measure the area under the curve. So we know that pi has to be more than 3.141. So pi is traditionally 3.141. I'm going to call it deficient pi because the true value, when you measure the area under the curve, is called 3.144 ... and it goes forever. And we know that this old pi is incorrect, and it's corrected, the code is corrected when we understand that the harmonics of the circle are based on the golden ratio, which is what we're going to talk about in this series. So I just want to go back quickly so when I talk about phi, we're talking about fractality, because the key to the universe is when systems can travel through time and space non-destructively, but they have to be what we call self-similar. And self-similarity is the mathematics of pine cones and sunflowers. So that's a fractal because the inside is the same as the outside. And we can see it again here. We can see it here again, that there's non-destructive energy going infinite. And that's what the true value of pi is going to create, a new form of technology. And this was done by Dan Winter. This was the first fractal called the heart zoom fractal that showed that the more you stare within the heart, it keeps making a copy of itself. So this is the pathway, a geometric series pathway to infinity. So by understanding pi and phi, we're understanding the mathematics of infinity. So I thought that was important, and I'm just going to go back to the very beginning. We just have a couple of minutes to explain that the keynote presentation I'm giving is asking the question, is pi a lie? We're not, all mathematics is sacred, so even the traditional value of pi, 3.141 is very good for its time, but and this is now called a correctional code. So we observe that distance of 0.144 is the error between 3 units. It's 3 plus that 0.144, and 0.144 is a harmonic of the speed of light. So if we had 3.141, the numbers don't fit. This is like a highly tuned instrument of the highest order. So that's the symbol for pi, represented like the letter P in Greek, whereas phi was the letter F. So the story is really a connection between the square and the circle. You can see how that's done in ancient Japanese and Chinese art. And in ancient times we had Jesus measuring the earth. He's holding a compass. So Jesus as a geometer is quite a powerful statement. It's all about, by knowing pi, we can measure the circumference of the earth, which is what the ancient Greeks did. So traditional pi is 3.141, and we're going to show that this has served its purpose, and we're saying goodbye to old pi because there's a new frequency coming onto the earth, and it's based on the golden ratio called the golden root, which is 4 divided by 1.272 gives 3.144. So what I'm saying here is we have symbolically the archer, and the archer is just about to release this new frequency called the true value of pi or Jain pi, but it hasn't been released because is it really the time now for this frequency to come out? Are we ready as a collective, as is our humanity now as a collective, are we ready to receive this knowledge from the gods? If this was like laser, if we were all given a laser beam and we had disputes with our neighbors, would we harm one another? Are we able to use this correctional code for the highest benefit of the planet? So this is what we call ecosophy, that the true value of pi is here to bring in a new consciousness, a new paradigm, and a new education that will develop the planet as a whole.